When we boil water to cook pasta, adding salt is a must. If you've ever forgotten the salt, you've likely realized how much of a difference it makes in the overall flavor of the pasta. But does salt do anything besides add flavor? According to some people, yes, it helps the pasta cook faster. But is there any truth to that? Let's dig into the science and see. So exploring this requires us to understand and explore the concept of colligative properties, which are essentially changes that occur to a solvent when we add a solute to it. For example, we might see a change in water's physical properties, like its boiling point or its freezing point, when we add a solute like sugar or salt to it. One of the most common examples of colligative properties in action is explaining why we add salt to roads in the winter. Adding salt lowers the freezing point of water, helping to keep roads from getting icy. So let's say there's a big snowstorm that we know is coming and we add salt to roads. When it snows, that snow, which is water, will mix with the salt to create a saltwater solution, and that solution is going to have a lower freezing point than if it was just plain water. As a result, a lower temperature is needed for it to freeze on the roads. Just like the freezing point of water can change when we add a solute like salt to it, the boiling point of water can also change. Specifically, the boiling point can increase in what is known as boiling point elevation. Thanks to boiling point elevation, we can make lots of sugar-based candies like lollipops, gummy worms, marshmallows, fudge, and more. All of these require a highly concentrated sugar solution, which is made by adding a ton of sugar to water and heating it. As we heat it, the solution gets more and more concentrated with sugar, which increases the boiling point of the solution. Take lollipops or tanghulu, one of our personal favorites, for example. They're made using a sugar solution that's heated to around 150 degrees Celsius. The reason why it's able to get to this high of a boiling point is because the concentration of the solution is around 99% sugar and 1% water. Exactly why these phenomena are occurring is all about phase transitions, the energy required for them, and attractive forces. But that's for another day. Based on what we're seeing with sugar, it actually might make sense that adding salt to water would increase its boiling point substantially, which would allow us to cook the pasta quicker. So to actually calculate boiling point elevation, we use this formula. So we're going to take a moment and break down the formula. You'll notice that we're solving for delta T, which is simply the change or the increase in the boiling point of the liquid by adding the solute. Next, we have Kb, which is technically the mole boiling point constant. The key word there is constant, meaning that every solvent is going to have a given and known value that we can look up. For our purposes, we just have to know that this number is never going to change unless we are using a different solvent besides water. The next variable is I, which is the Van't Hoff factor, which is a way to account for how many dissolved particles a solute creates when we add it to water. For salt, it's 2, because sodium chloride dissolves into 2 ions, sodium and chloride. If we were to go back to our sugar solutions, which use sucrose, the Van't Hoff factor would be 1 because sucrose does not dissolve into multiple ions. The last variable, m, is the value we are actually changing. It's essentially measuring how much salt we're actually adding and how concentrated the solution is with salt. Technically, it stands for mole concentration, which is moles of solute per kilogram of solvent. While an understanding of what a mole is and molar mass is helpful for calculating this, conceptually what you really need to understand is that the more salt we add, the higher this value will be. It's simply another way to express concentration, similar to how we might say it's 5% salt, but we're just using different units. Basically, we can calculate this by knowing the amount of salt that we added in grams, using salt's molar mass to then convert that into moles, and then dividing that by the mass of the water. Okay, let's do an example. Let's say you have a medium pot of water and you add a tablespoon of salt to it. That pot probably holds about 8.5 cups of water, which is 2 liters or 2 kilograms of water. Now, the exact mass of the salt will depend on the brand that we use, but let's say we use Morton kosher salt. This would be 16 grams of salt. Doing some math, we can see that this will be 0.27 moles of sodium chloride. We then divide that by the amount of water, which is 2 kilograms. This results in a molality of 0.137. We then can plug in our values for K, B, and I, which are going to be constant as long as we're using water and salt. Multiplying these values shows that we have a change in temperature of 0.14 degrees Celsius. So what that means is that instead of the water boiling at 100 degrees Celsius, it will boil at 100.14 degrees. So yes, technically the boiling point is increasing, but this is a really small amount. So how much salt would we need to add to increase the boiling point by a degree? Before you try it out yourself, we want to point out a couple of things. Conveniently, the values for KB and I pretty much cancel each other out. So our final change in temperature is essentially our value for M. And even if the units when calculating molality are less familiar to you, all you really need to know is your mass of salt in grams and your mass of water in kilograms. And you just plug those in. Pause here to try it out yourself. So here we're going to look at 3 examples of how much the boiling point changes when we add a tablespoon, 2 tablespoons, and half a cup to 2 liters of water. As we already calculated, when we add 1 tablespoon of salt, the boiling point is now 100.14 degrees Celsius. When we add a second tablespoon, that increases just a little bit more to 100.28. When we add in half a cup or 128 grams of salt, the boiling point is now 101.12. Yes, that's right. We literally have to add about half a cup of salt to increase water's boiling point by a degree. So basically our conclusion here is that the amount of salt we would have to add to water to meaningfully change its boiling point would make the pasta so salty that it would be inedible. So in our typical scenario, the amount of salt we're adding to our water when cooking pasta is going to be negligible and is not going to speed up the cooking process. Thanks for tuning in on this episode of Bite Scized. Be sure to like and subscribe for more videos.